So we are beginning. I want everyone like locked in, okay? Since there was no warm-up yesterday, make sure you actually write no warm-up for Monday, and you're writing this on Tuesday, okay? Now, theoretically, you could have and should have been able to do this from like years past information, but I understand that it may not be fresh on your mind, and maybe you didn't learn it because maybe you were in a Zoom room instead of doing this in a classroom. I get it. So this warm-up is me kind of showing you how to do this algebraically before we do the notes, where you definitely need to know how to do it. So this warm-up is not just like whatever, very important, okay? So here we go. By the way, it says Quiz Thursday. I added a question mark because we might push it back a day, maybe 2 days behind. It's okay, we'll see it. Now, let's solve for y. If I'm solving for y needs to be by itself. So everybody, what do you think I should get rid of first on this right-hand side over here? What's the loner? Plus 2. You see that? Like I can't get inside the square root. I can't get rid of the square root. I'm going to get rid of the 2 first. And it's positive, so what am I going to do? Minus 2. So everybody write that down. Minus 2 here and minus 2 here. X and minus 2 do not combine. They are 2 different. So I'm going to put the minus 2 after the x. So it looks like this. I like to draw a little arrow to remind myself that goes after the x. Okay. So I have x minus 2 equals square root of y minus 5. Let's make that look a little nicer. Now, before I can get to that minus 5, I have to get rid of the square root. Does anyone know what the opposite of square root is? So it's actually within the name. The opposite of square root is just square, squaring the little 2, okay? Does everyone hear me say that? So the opposite of square root is square. So here's what you do. You put a little square on the right side, cancels it out. And then on the left side, put that whole thing in parentheses, squared. To get rid of the square root, you square the whole, both sides. Now, I'm going to bring this down. X minus 2 squared equals y minus 5. My last step, how do I get rid of a minus 5? Plus 5. Now here's the dealio. You're not going to add it inside the parentheses because you can't get that far in, okay? You just like last time, you put it at the end. Okay? Like when you're adding things, you just kind of tack it on at the end. So here's how I'm going to write it. Y equals x minus 2 squared plus 5. So this is just part of what we're doing today, but this is an important part. So can you solve for a variable that has got a whole bunch of other junk there by getting rid of the loner, doing some opposites, getting it the y by itself? That's a very important part of today. We're going to keep doing it over and over. So there it is. Here's an example. Now we started with the square root. We ended up with the square. So example 2, we're going to start with the square, end up with the square root. Okay, you should be able to go both ways. So look at number 2. What do you think I should get rid of first to get y by itself? Before the square, we have a loner. The minus 7. How do I get rid of that minus 7? What do you think? Yeah. Wow. All right, plus 7. I need you locked in. I need your mind locked in, like you're playing a riff. All right. So the minus 7 and the plus 7 cancel out. Got x plus 7 equals y plus 3 squared. Before I can get rid of this 3, I need to get rid of the square. What's the opposite of square? Square root. Okay. So squares and square roots, they always are opposites. Cool. So here's how you write it. You're going to put a square root sign on the whole right side and a square root on the whole left side. It cancels out on the right. So now I have square root of x plus 7 equals y plus 3. What do I do for my last step here to get rid of that plus 3? Minus 3 on both sides. And just like before, you're just going to tack it on at the end. I don't want you to actually do 7 minus 3 because the 7 is stuck inside of a square root sign. You can't mess with it, okay? So here's my final way of writing it. Y equals square root x plus 7, and the minus 3 goes after the square root. It absolutely does matter where the square root sign ends. So make sure it's x plus 7 underneath. The minus 3 goes after it, okay? And that's a good warm-up. Now, don't forget anything I just went over with you. We're going to use that as we go over this. So, stay with me. I know this is going to be a couple of things. But we're going to get it. Easier. Lemon squeezy. Here we go. So we are going to be able to find inverses of quadratic functions and square root functions. So let's move on. All right, you don't have to write this down. If you do write it down, I would write it on the bottom left corner so you don't take up any space you need on the right. But these are, what's the opposite of plus? Okay, what's the opposite of multiply? Divide. What's the opposite of square root of x? Square. Okay, so square root, square, those are opposites. They cancel each other out. So those are the 3 kind of inverse operations we've talked about before. Now, let me tell you, if you were going to summarize everything we talked about today in one word, it would be switch or swap. Basically, this. So if y equals x, the inverse is when you just switch the order. So what would that be? Flip that around. What do you get? X equals y. That's it. Switching x and y is literally what an inverse is. It inverts it. Okay. Now, if you were to invert 1, 3, take a wild guess. What would that be? Switch the order, and now you have 3, 1. Solid. Okay. So that's just a reminder of inverses. Inverses switching x and y. We're going to apply this to a function here. Now, as usual, on the left-hand side, you have all the steps you need. So in the future, if you're stuck on something, you go back in time and look at all the steps I gave you and all the examples I gave you so you're not stuck in waiting for me to be there when I'm not there. All right, so step 1, graph this function. Now let me ask you, in all honesty, can you take this equation and graph it? What's the easiest way to do it? That's harder. Okay. What's the easiest way to graph on a piece of paper? If you can get a bunch of points from an equation, you can plot those points, right? So I'm going to tell you something you already know. Can't you graph this in the calculator here and press what to get the table? Control T. Control T, right? And if you get a table of values, can't you plot those points on a piece of paper? I'm telling you, if it tells you to graph, you first graph it here, Control T, and then plot those points. Easiest way to do it. There's other ways to do it where you're just like thinking about it. Well, this moves to the right 2 and up 1, and I'm going to shift it. And you can do it other ways, but I'm telling you, if you want the surefire way that's going to work every single time, you want to graph in your calculator, Control T, plot points. Okay. Now, if you were to do that, which I'm gonna fast forward. I'm gonna pretend like I just did that. Type. You're gonna end up with a graph that looks like this. If I can get there. Okay, here we go. So go ahead and plot these points, 2, 1, 3, 2, 6, 3. Plot these points, please. We are moving fast and furious, so make sure you're following along here. So you should be able to graph it in your calculator, press Control T, get those 3 points, draw a nice little square root graph. Cool? That should be old news. Does everyone know how to do that? For sure? Okay. Step 2, we're going to use the graph to determine the domain and the range. Okay. So domain. How far to the left does it go? 2, and then it goes up forever. So x is greater than 2. What about the range? How far down does this go? 1 and up forever. So y is greater than or equal to 1. So go and write that domain and range off to the right, not below it, off to the right. Down. So, step 3, we're going to swap x and y. Now, everybody, this is where we're going to use what we just did on the warm-up. Does everyone still remember what we did on the warm-up, hopefully? Here we go. So below, in that space below the graph, here's what you're going to do. Okay? Step 3 is we need to swap x and y. So first, does everyone know f of x is the same thing as the letter y? Like, you know, this is basically a y. So let's just go ahead and rewrite that. So go ahead and write this. Y equals 1 plus square root of x minus 2. Please. Okay, everyone wrote that down? So now we're going to do step 3. Swap x and y. This y becomes an x. This x becomes a y. So it's going to look like this. Right? Make perfect sense so far? Think so. So again, you write it with the y, you switch x and y, and now this is like the warm-up we did, the very first problem. If I want to solve this, step 4, if I want to solve this for y, what would I need to get rid of first over here? The 1. Does that make sense? The lower 1. How do I get rid of a positive 1? Minus 1 on both sides. So let's do that. Minus 1 here, minus 1 here, and you put it after the x. Cancel that out. You got to be able to do these multi-step, yes. So whoever made this did that. You don't really have to write the parentheses. Here's why they did it though. People get confused on whether the numbers are inside the square root or outside. So it's kind of a way to contain it and think this is inside. But if you don't write it, no sweat. Next step, should I get rid of the square root or the minus 2 next? What do you think? Okay, you can't get to that minus 2 because it's under a square root sign. You must get rid of the square root. What's the opposite of square root? Square. So you better square that root. So square the right side and square the whole left side. So on the left side, we have x minus 1 squared equals y minus 2. Okay. Last step. How do I get rid of that minus 2? Plus 2 on both sides. So check it out. Plus 2 here. And the plus 2 on the left side is going to go after the parentheses. This is literally what we did on the warm-up. Everyone has it written down? Step 5, instead of the letter y, we want to write this thing, which means f inverse x. So let's write it as an inverse function. Y is going to become this, and all of this comes over here. That's how you write it as an inverse function. F little negative 1 parentheses x. F inverse of x. Cool? So that's how we write it. Now, real quick, let me back that up 1 second. Do you see in step 5, it says to swap the domain and the range, okay? What was my original domain? My original domain was x is greater than or equal to 2. My range, y is greater than or equal to 1, right? So for my new domain and range, I want you to see this swapped down here, this swapped right here. Do you see how the domain and range has switched numbers? Very important. It's right there. I said it. You wrote it. Okay. But again, the original domain was greater than 2. Now that's the range, greater than 2. The original range was greater than 1. Now my new domain is greater than 1. They have to switch. What's the one word that we have to talk about with inverses? Switching. X and Y switch all the time. I wish we were done with number 1, but now our last step is we have to graph it. I'm telling you, today's a lot of stuff. I'm not going to lie. So now can you graph that new graph on this graph? Right, on the same graph. So this is what it looks like. This is what it looks like. Okay. If you take that new graph, you put it in the calculator, you press Control T, you get a bunch of points, okay? You're gonna get these 3 points, 1, 2, 2, 3, 3, 6. So those inverses look like that. Now, what do you notice about those 2 graphs and that green line? What's a good word for what's happening between the red and the blue? They are inverses, but like the transformation language. What happened across that line? Imagine you're at the Krabby Patty, and you're going to make a Krabby Patty, and you're going to get that. Oh, it flipped. Wow. Okay, so, or reflected is another good word. It reflects across that green dashed line, which is y equals x. Okay. I'm telling you, every one of these inverse functions is going to be symmetrical and reflect across that diagonal line, y equals x. The domain and range are going to flip. The equations are going to switch and solve. This is how it all works. Nice, perfect, symmetrical harmony between inverses, okay? That's just example 1. So we have another one. If you got that written down, you can flip it over and let's look at example 2. Please. Okay, now you'll notice this one starts with a square, but it has this thing right here. Do you see what I am underlining? This is what we call a restricted domain. A restricted domain means it's only part of the graph. And I'm going to show you why, especially on the 3rd page here. But let's go ahead and look at step 1. We're going to graph this function. Okay. Now again, I know you can go to your calculator. You can type it in. You can press Control T and you can plot some points, right? But the graph, they only want greater than or equal to 2. So the only points you really need are 2, 2, 1, 3, 2, 4, 5. You only want to the right. You don't want to the left. So if you draw that dashed line, that's okay. but we really don't need the dashed line. We only care from 2 to the right, okay? Now let me tell you why, Mr. G, are we cutting it in half? Just randomly, just because you say so? Well, no, here's the math reason why. Do you see on step 1? Whoops. Click. Okay. Do you see on step 1 it says to conduct the horizontal line test? Do y'all remember algebra 1 doing the vertical line test, maybe? To tell if something's a function? Maybe. Vertical lines cannot go through more than one point, or it's not a function. So this is basically the opposite. A line cannot go through a graph more than once horizontally, side to side, otherwise it has no inverse function, okay? So it's kind of weird. Even though this is a function, if the horizontal line test doesn't work, then it's not what we call 1-to-1. And we're going to see that on page 3. But for now, trust me, since the diagonal line would go through 2 points, we cut it in half. We start at the bottom and we go to the right. So does everyone see? We call this the restricted domain. So that's from 2 to infinity. So x is greater than or equal to 2. And my range, the bottom is what? What's the bottom? 1, right? Up forever, so my range, y is greater than or equal to 1, okay? Okay, now, we're gonna do that equation thing again that we did last time, like we did on the warm-up. Ready? So below that, where you have all that space, go ahead and write your function with a y, okay? So that f of x becomes a y. Hey, did you write that? So underneath it, go ahead and write y equals x minus 2 squared plus 1. Okay, now step 3 says to swap x and y. So y becomes an x becomes a y. Go ahead and write that, please. Now, remember the warm-up. What should I do first? What do I need to get rid of first? The loner is plus 1. How do I get rid of a plus 1? The opposite of plus 1 is minus 1. So on both sides, I'm going to put a minus 1. Looks like this. If it clicks. Okay. Minus 1 here cancels out. Minus 1 here goes after the x. Okay? So we end up with x minus 1 equals y minus 2 squared. Next step, should I get rid of this minus 2 or this squared? Okay. I can't get to the minus 2 until I get rid of the square. So to get rid of a square, what's the opposite? Square root. So I'm going to square root both sides. Now, this is where it's going to start looking weird. Follow me here. When I square root the right side, it looks like this. Cancels out that. Radical. And then on the left side, I put the radical. Now, this is something you should have learned, and I'm just going to say it. Whenever you take a square root, there's always 2 answers. There's a plus and a minus. So that's why in front of the square root sign, there's a plus and a minus, okay? I'll give you a quick example. What's the square root of 4? What multiplies to make 4? 2 times 2 and negative 2 times negative 2. They both give you a positive 4. So there's always 2 answers to a square root, just saying. That's why there's a plus minus sign in front. Last step, how do I get rid of that minus 2 after it? The opposite is 2. Add 2 here. And they added 2 to the front of this, which is fine. So that's what we get. And I'll post this in the Google Classroom if you don't want to get from someone else later. Now, step 5, we want to write, instead of the letter y, we're going to put f inverse x. So that comes down here. The whole left side comes over here. This is how you take a squared function, a x squared quadratic function, find the inverse, that's square root. Okay, now I know this so far has been like chewing raw meat. It's been like, it's a lot, okay? This next step is the worst part of it all. So I'm just gonna mentally prepare you for this. Ready? Here we go. And I can stay on this slide longer. Yeah, nope. Okay, we're good. So now I'm gonna put it all on the board and just explain it. Here we go, okay? Now, here's what they want you to do. Do you see that we started with a restricted domain, x greater than 2, okay? We found our inverse function, 2 plus or minus the square root of x minus 1. Here's how you tell which one is true. You're basically asking yourself, is it the plus or do you use the minus? Okay, here's how you tell. You're going to pick some number that works with this. So pick a number greater than or equal to 2. 3, right? Or what they picked is 5, okay? It doesn't matter. So 5 is greater than or equal to 2, so here's what they did. They picked 5, and they plugged it into this x. But on one of them, they used the plus sign, and on the other one, they use a minus sign, okay? Now, when you do that, and you do 2 plus square root of 5 minus 1, you end up getting 4. When you do 2 minus square root of 5 minus 1, you end up getting 0. Who cares? Here's why it matters. It needs to be in the range, and we said that the range was greater than 1. So you tell me, is 4 greater than 1 or is 0 greater than 1? 4. See what? So before you switch anything, you're thinking, what's the original domain and what's the original range? Which was x is greater than or equal to 2 for the domain, and the range is y is greater than or equal to 1. Okay, so the domain x is greater than or equal to 2, the range y is greater than or equal to 1. So I picked a number greater than 2, I plugged in 5, and the only one that gives me something greater than 1 is the 4. Okay, all that to say, why did we do all that? Because the plus sign wins. The plus sign actually makes sense. So that's why right here in my final answer, there's a plus sign. Okay. Now, theoretically, it'll be on Google Classroom if you don't write it down. You can always get there. But also, I don't have a lot of time to waste on this, to invest on this slide, so we got to get to page 3. But I will say this. Okay, I will say this. I'm going to be lenient on this part of it because I really want you to, more than anything else, be able to get the inverse function, graph them, okay? When you graph them, you're going to see, it's going to be obvious which side it should be, okay? Because remember, it's going to reflect across the diagonal line, okay? So you do want to make sure you write down this bottom part that I'm going to highlight here in yellow there, for sure, okay? Cool? Does everyone have that bottom part? You have the inverse function, you have the new domain and range. So the domain did flip to the range, and the range did flip to the domain. We're almost done with example 2, because now we have to go back to the graph and make sure we graph it. I know, it's like a million bajillion steps, and that's a technical math term. I promise you, we're not doing anything that the other Algebra 2 teachers are not doing, so we're just doing a lot. I want you to miss something important. So you can if you have to. If you really need to, go ahead. But rather you, if you can, be here for the last page. It's up to you. Okay, so okay, back to the graph. So when you graph it, so go ahead and graph this for me, please. When you graph that new graph, okay, you're gonna get this red graph, okay? 1, 2, 2, 3, 5, 4. Those are your points. And you can see that it reflects across the diagonal line. They're symmetrical, okay? They do a flip reflection across that line, y equals x, diagonal line. You can see the domain and range have swapped. You can see the graph is reflected. Everything's nice and works out, okay? Okay, flip it to the third page. Okay, this is going to be short, I promise, okay? Everyone with me, going to the next page. Okay, I've already alluded to this stuff, so I'm going to just say this real quick. To get an inverse function, your function has to be called what we call one-to-one, which means every domain has one in the range, every range has one in the domain. Basically, it must satisfy the horizontal line test and the vertical line test, okay? So watch me do this. You can draw this with me. If you draw horizontal lines on this first one, do you see how it only touches it once? That's Gucci. Second one, if you draw horizontal lines, even right here, it only touches once. That's busted. But the third one, if I draw a horizontal line, do you see how it touches it twice? Failure. Big fat failure, okay? So let me just make this super easy. Anytime you see this shape, it's called a parabola, looks like a U, it don't work. So you're gonna have to cut it in half. Every time you see a U shape, you have to cut it in half for sure, okay? When you're doing inverses. So look at this next little section on the same page. They want you to do it on these graphs. Cut them in half. Make them usable. I can't use them right now because look, it touches twice. It touches twice. It touches twice. But it will work if I cut off half. So here's how you do it. Put your pencil on the vertex at the very bottom, and then just shade along the edge to the right. That's all I need, that half. You can do it on the middle one too. Do it right now. Go put your pencil on the vertex, make a point, shade it to the right. That's all I need, cutting it in half. Put your vertex, shade it to the right. That's all I need. Okay, now, can you tell me the domain and the range of these half graphs? Okay, so go to the bottom. What's the x value right here? 3. So x is greater than or equal to 3. Okay, what about the range? What's the y value at the bottom here? 1. So y is greater than or equal to 1. The range is y, and y is over here. Okay. What about this one? What's the x value? The domain right here. -3. So it's x greater than or equal to -3. What's the y value at the bottom? Y is greater than or equal to what? -2. Last one, x is greater than or equal to -4. Y is greater than or equal to -2. Okay. That's for the half graph. That's called a restricted domain. The last part of this page is going to ask you to take that information and get the inverse. What's the only thing you have to do to get the inverse with this?
Negatives.
Not negatives. Switch them. That's it, right? Remember, inverse means switch. Switch, switch, switch. That's all you're doing. So my new domain in my new range, x is going to be greater than or equal to what? 1. Y is going to be greater than or equal to 3. Do you see how I just switched them? X is greater than or equal to -2. Y is greater than or equal to -3. X is greater than or equal to -2. Y is greater than or equal to -4. All you do for an inverse is switch the X and the Y. Now, I know that was a whole lot. Okay? It's not over till it's over. So what I'm going to do, I'm going to hand you the assignment, and we're going to do number 1 together. I'm going to hold your hand through the whole process. So that way, you know what to do when you're going to do the assignment. Right? All right, cool. So I'm going to do 1 with you. Which one should I not with the 1? Yeah, I forgot to put that in. By the way, that 1 blank on the back is quadratic. Quadratic does not work the way it is. That's why it's restricted domain. And I'll go out today. We'll get it done here soon. Okay. Okay, here we go. Let's take a look at that assignment. No problem. I'm here to help. Number 1. Look at number 1. Can you graph that? I said it earlier. What's the easiest way to graph this? What do I use? Okay, calculator. So let's go ahead and I'm going to go to a new graph. Number 2. Type it in. 2 plus square root x minus 3. Can you take that graph it here? What do I press now to get points? Control T. Don't worry about the undefined stuff. Just go down until you get some good points. So 3, 2, 4, 3, 7, 4. Plot those points. Oops. That should not be the hard part. Is everyone able to get points from it? Okay, now, here's the part where you got to think a little bit. Ready? Take that equation, turn f of x into the letter y. What? Here. That's one more back. Now, what do I got to do with x and y? What's the very important step I cannot forget? Before I start messing with it, what do I have to do with x and y? Switcheroo. You have to switch it, okay? So, let's go ahead and write that. X equals 2 plus y minus 3. Is everyone hearing me say that? Very important step. You have to switch x and y. Now let's start to try to solve this. So what did you say? What should we do first? To get rid of that positive 2, I'm going to do minus 2, minus 2. Put the minus 2 after the x, right? You can go to the main office. They're calling you down. Next step, to get rid of a square root, what's the opposite of square root? Square. So x minus 2 squared equals y minus 3. What's the opposite of minus 3? Plus 3. And the plus 3 goes after. I'm going to write the final form. F inverse x equals x minus 2 squared plus 3. That's just like the warm-up we did. If I type it in my calculator, the new graph, I hit Control T, and I'm only going to plot points from the vertex to the right. That starts right here, those 3 points. 2, 3, 3, 4, 4, 7. Doesn't that look like it's symmetrical across this diagonal line? Okay. I know that was rushed and a lot compacted into a little bit of time, but that's all we did on the notes. It's on this video that you can get on the Google Classroom. I'm going to upload the key for the notes and everything on Google Classroom. Okay. Have a good day. You definitely have tomorrow to work on this, so don't sweat it. See ya.